Hi, welcome to Hayward's Maths. If there's an example you're looking for, here's the list. Check out the one you need. Hope it helps.
We're all on the same page. We're trying to get the probability of the Z being less than 2.2. Yeah? So you open up your TI, go to menu, then to what? Menu, then 5. Oh, I thought you were putting your hand up. Distribution, and then normal cumulative distribution function. This is your lower bound, negative infinity. What's your upper bound? 2.2, the z-score. We've got the normal distribution mean, which is 0, and the normal distribution standard deviation, which is 1. And that gives us the probability of the z being less than 2.2, 0.986097, or 98.6% approximately. 2.2, so we wanted this area in here, this area under the graph. And we found that this area under the graph was that. This time we're going between two, right? Negative 1.2, 1.2, and what do we know about the shape of the normal distribution? It's symmetrical around the mean, very good. And the mean is 0 because it's standard normal. So if we find this area, what can we do with that area? Perfect. The whole thing, the whole area is equal to 1. So if we minus this area twice, or 2 times the probability that Z is what? Z is negative, less than negative 1.2. So if we find that area, which is Z less than negative 1.2, the probability, multiply it by 2, minus that away from 1, we'll get the answer. Is that what you all did? So let's try. Take this, go from negative infinity to negative 1.2. That gives us that red area in here. 0.115. What the? 507. So we take 2 of those away. So that is that area in the middle, which is that. All right, next one. What does that look like graphically? Greater than 1.5. Yep, everything, this area under the curve here. So everything, so how do we do that? The clues in what I said before, it is symmetrical around the mean. So if we find the area up to what? Negative 1.5, if we find this area and minus, that'll be the same as that area, right? So this is equal to probability of Z less than negative 1.5. So same thing on your calculator, and this time go up to, so did you all get that? Internal. Collected some golf balls, recorded their widths, and I had a mean of 28 millimeters and a standard deviation of 3 millimeters. Determine the probability that the random variable The golf ball width is greater than 29 millimeters. Any thoughts? Back to this, menu probability distribution, normal. What's the upper bound this time? Let's go back to the question. It says x greater than 29.
So the lower bound is 29 and the upper bound is the biggest number you can chop in there. It's not infinity.
Different solutions coming around. If the mean is 28 and it wants us to find 29, so it wants us to be greater than that. It's symmetric around the mean, so what's on the other side? 27. So this area should equal that area. Does that make sense? Up to 27. We have a standard deviation of 3. So we can just put that into the calculator, can't we? 27, 28, 3. Let's see if they all get the same answer. Just to make sure that I'm actually doing what I say. Same answer. And what was the other way? Oh yes, 1 minus that one. Up to 29. So yeah, 3 different ways to do it. And you all get the same probability of getting a golf ball greater than 29 millimeters wide. All right, next one. It says convert x to z. So what do we do? Yep, use this equation. Z equals x minus mu over standard deviation. So what's the x score? 29. What's the mean? What's the standard deviation? 3. So we have a z score of 1/3 for 29 millimeter width. Does that make sense?